If you are not familiar with the concept of Pythagorean Theorem or you are not able to solve problems on it, this video is the only thing you will ever need. By the way, this chapter is presented in two parts. In the first part, which is this video, we are going to talk about the concept of this theorem and we are gonna solve some straightforward and simple questions. For more complicated and challenging questions, I strongly suggest you to watch the second part as well. I'm gonna put the link of that video in the description.
So Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test. So Rab explains it best.
As always, we are going to start with the definition. What does it mean when we say Pythagorean theorem? Based on this theorem, in a right triangle, so this is the first condition, pay attention, it is really important. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the leg. Okay, this is really simple. You could easily find it by googling that or searching that in a AI software. But what is the meaning of that? What is the concept behind this definition? I'm gonna explain that, don't worry. Assume that we have a right triangle. This is really important. This is the first condition that must be fulfilled to use this theorem. I must have a right triangle, and as you can see, this angle is equal to 90 degrees, right? In a right triangle, the sides that are perpendicular to each other, the sides that they form a 90-degree angle, in this example A and B, right? Because they are perpendicular to each other, they form a 90-degree angle, are gonna be called legs, and the side which is in front of, opposite of the 90-degree angle is gonna be called hypotenuse. It's clear that hypotenuse is the longest side. Based on Pythagorean theorem, whenever I have a right triangle, I can use this formula. C squared, C stands for hypotenuse, as you can see, is equal to A squared, one of the legs, plus B squared, the other leg. Really easy. Let's solve some examples with each other. Look at the first example again. I have a right triangle and I have a missing side. So the first thing that must come to my mind is Pythagorean theorem. I'm gonna write the main formula here at the top. C squared is equal to A squared plus B squared. Really easy. Okay, what is C in this example? C stands for hypotenuse, right? So the value of that, as you can see, is x, and I want to find it. I'm gonna replace that with x is equal to, which one is A? Which one of the legs is A? It does not matter. Okay, you can assume here 12 centimeter is the A or 5 centimeter is the A. It is totally up to you. Here I prefer to assume that 12 centimeter is representing the A and 5 centimeters is B. If I simplify that, what am I going to have? I'm gonna have x squared is equal to 144. 12 squared is gonna be 144 plus 25. And if I add them, what am I going to have? If I add them, I'm gonna have x squared is equal to 169. For the next step, I'm gonna take a square root from both sides. And finally, the final answer and the missing side would be x is equal to 13, because 13 times 13 would be 169. Here you may ask, okay, I know that one of the answer when I take a square root would be 13, but negative 13 is the other answer. I know that. Yes, it's totally correct when you are solving an equation. But here I'm talking about the length, and as you definitely know, lengths cannot take negative values because it does not make any sense. It does not have any meaning. So when I'm talking about the length, the only acceptable values are positives, right? So x is equal to 13, not negative 13. Look at the next example. Here, x, or the missing value, is one of the legs and not hypotenuse. Okay, I'm gonna write addition of squares of legs, x squared plus 6 squared is equal to 10 squared. Really easy. So I'm gonna write x squared plus 36 is equal to 100. Okay, here you can easily solve that based on inverse operation or transposition method. It's totally up to you. I'm going to solve this one based on inverse operation. I want to make the variable alone, so this 36 is extra. I'm going to subtract this side by 36, and every operation that I do with one side, I must do exactly the same with the second side, so minus 36, right? So these two are going to cancel each other out, and if I add them, of course, I'm going to write the rest here. X squared 100 minus 36 would be 64, and if I take a square root from both sides, I'm sorry, here I do not have enough space, x would be equal to 8. Really simple, and negative 8 is not acceptable, so I'm not going to mention that at all. Look at the next example. Again, in this example, the missing side is hypotenuse. So x squared, based on Pythagorean theorem, is equal to 7 squared plus 5 squared. So x squared would be 49 plus 25. If I do that, I'm gonna have x squared is equal to, if I add these numbers, what am I going to have? I'm gonna have 74. So I'm gonna take a square root from both sides, and if I do that, you can easily realize x would be equal to radical 74, or a square root of 74. Here, because the answer is not a whole number, because 74 is not a perfect square, I can leave it like this. And most of the times it is acceptable. For example, if I were your teacher, I would accept this answer. But the point is, it's totally up to your teacher. If your teacher wants the answer of this one, he expects you to simplify that, you can use calculator, or you can write the approximate answer. For example, if I do not want the precise answer, it would be a square root of 74 would be between 8 and 9. So it would be, for example, you can assume that this is 8.5. It's totally up to you. But here I'm gonna accept radical 74 because the answer of that is not a whole number. Look at the next example. Here the missing value is a leg. So I'm gonna write the Pythagorean theorem because I have a right triangle. So x squared plus 4 squared is equal to 10 squared. Really easy. Again, x squared plus 16 is equal to 100. This time I'm gonna solve it based on transposition method. I'm gonna move this number to the other side and I'm gonna change the sign. So positive 16 would be negative 16. So what am I going to have? I'm gonna have x squared is equal to 100 minus 16, right? So x squared would be equal to 84, and I'm gonna take a square root from both sides, and as you definitely know, 84 is not a perfect square. So what am I going to have? I'm gonna write it here because here I do not have enough space. I'm gonna have x is equal to radical 84. Really easy, or a square root of 84. Here there is a point which is really important and can decrease the amount of calculation that you are supposed to do significantly. We call it Pythagorean triples. What does it mean, Pythagorean triples? There are two sets of numbers that follow the Pythagorean theorem, and it would be really good for you to memorize them. Why? Because teachers love those numbers, and it does not matter which side are you finding. As long as you have these numbers, the answer would be a whole number. So probably you are gonna face these numbers in the exam. Okay, what is the first set that we need to learn? 3, 4, and 5. if the legs are 3 and 4, the hypotenuse would be 5 in a right triangle, of course. Okay, first set contains several subsets, and it would be great for you to know that. What are the subsets? The subsets can be obtained by multiplying any positive number. When I say any positive number, it can be a whole number, it can be a fraction, it can be a decimal, by all the numbers in this set. Look at the first example here. I definitely know that 6, 8, and 10 are following the Pythagorean theorem. Why? Because 6 is 3 multiplied by 2. All of them must be multiplied by same number. 4 multiplied by 2 would be 8, and 5 multiplied by 2, definitely it would be 10. And look at the next example. 12 is 3 times 4, 16 is 4 times 4, and 20 is 5 times 4. So all of the numbers in the set are multiplied by 4. Really simple. So the first set is 3, 4, 5. What is the second set? The second set is 5, 12, and 13. And definitely it has several subsets that can be obtained by multiplying any positive number by the numbers inside this set. Look at the first example, 10, 24, and 26. As you can see, all of them are multiplied by 2. And look at the next one, 25, 60, and 65. All of them are multiplied by 5. So definitely they are gonna follow the Pythagorean theorem. Can we have more sets of these triples? Yes, of course, we can have several sets, but you do not need to memorize all of them, because if you have them, you can easily use the Pythagorean theorem and you can find the missing value. But these two sets are really famous and teachers love them the most, so I strongly suggest you to keep them in your mind. I'm gonna solve some examples to teach you how to use these sets. Look at the next example. I have this side. This is 12 and this is 16, right? And I want to find the hypotenuse. Here I have a right triangle. I can easily write the Pythagorean theorem and find the value of x. But if I want to do that faster, I'm gonna take help from Pythagorean triples. If I take a look at it, I would realize that this side is 3 times 4, right? And this side is 4 times 4, because 4 times 4 is 16. So I have 3 and I have 4. So I'm gonna remember the first set, 3, 4, and 5. So this side must be 5 times 4. It would be 20, and because of the unit of other legs are centimeter, this one would be 20 centimeter. Really easy. Look at the next example. In the next example, I have 6 centimeter and I have 2.5 centimeter. If I pay attention, if I am clever, I can easily realize that this 6 is 12 divided by 2. And this 2.5 is 5 divided by 2. So what do I have? I have 5 and 12. I am going to remember the second set, 5, 12. So the hypotenuse must be 13, but divided by 2, it would be 6.5 centimeter. I told you it's totally up to you if you want to memorize these sets, these triples, or not. Some students want to be average, some of them want to be more clever and faster than the other ones. It's totally up to you. Look at the next example. Here, this 9 is 3 times 3, and this one is 5 times 3. So I can easily find the first set here, 3, and the hypotenuse is 5. So this one must be 4, but times 3, which is gonna be 12, and the unit is centimeter, as you can see here. Look at the next example. I can easily realize that this one is 3 times 12 and this one is 3 times 13. So I have 13 and 12. The second set will come to my mind. So this one must be 12, 13. So this one must be 5. But times 3. Because all of the numbers in that set are multiplied by 3. Is gonna be 15 centimeter. Really, really easy. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.